Hello everyone, I am Jamal Nasir and welcome to CS-101 course named as Introduction to Programming. In this course, we would be using or learning Java programming language. As this is the first one lecture, so you don't need any previous lecture to watch. So what this course is about? This course is split into two major themes. First one is computational thinking and computational principles. How can you use computers to solve problems? So this is computational thinking. Obviously, for solving problems, we would be using some programming and we would be using this programming as a tool. And this tool would be Java. So in this course, we would be learning from basic to advanced concepts of Java. Course learning objectives. So we have 5 course learning objectives: computational thinking, functionality or behavior, control structures, data abstraction, and code quality. So what is computational thinking? It is knowing how to break down and solve a problem in a way that a computer can do it. So it's just a divide and conquer strategy. So you have to think that how you can break down your problem into a small sub problems, then you can easily handle that sub problems. In functionality, we have to write functionally correct Java programs that meet a provided specification or solve a specified problem. So control structures, select and apply control structures like loops, methods, conditions to manage the flow of control and information in programs. Control structures. Data abstraction, select and apply basic data abstractions like variables, parameters, arrays, classes to manage and manipulate data in programs. Code quality, define programs that are well written, readable, maintainable, and conform to established standards. So this is very important as well. Why study computer science? Nowadays, in every field, all fields of studies or all areas of employment, people are using computers. They are using computer science applications, either it related to art, drama, like or some other things like ticket sales or lumberjacking. So yeah, so everywhere you can see or everywhere you can see different applications of computer science in every field, in biology, in chemistry, in physics. So computer science is everywhere. So computer science has massive impact on our lives and society as a whole. We can see a lot of applications of computer science, like in terms of commercial drones. You can see, like, we have Amazon is using this sort of technology, or even Uber is using this thing, right? In terms of intelligent apps, we have like Fitbit, right? Or all of you are using Google Calendar thing. Virtual assistants, we have Cortana, Siri, we have Alexa, right? So in terms of blockchain, Bitcoins are famous nowadays. And like autonomous vehicles, Tesla, Google, right? So we have so many applications nowadays. So 24 years ago, what was the hottest technology at that time? Windows 95, DVD players, Sharp mini disc player, Sony PlayStation, first edition of GTA, web TV thing. So yeah, but now computing in your future, obviously computing and its data are inescapable, right? We are generating a lot of data. We have digital footprints of all the time what we are doing. We are sharing it on social media. So we are generating digital footprints, right? So computing is a regular part of now every job. Use computers and computational tools, generate and process data, dealing with IT people, understanding the computation proportion of projects. So our goal is to help you make sense of the digital age that we now all live in. as I told you earlier, that in this course we would be focusing on two major themes: computational thinking and learning Java as a programming tool. So about something about programming, obviously that programming is not equals to computational thinking, right? So computational thinking is knowing how to break down and solve a problem in a way that a computer can do it. It's some sort of logic, it's some sort of algorithm. You have to define in steps, you have to define in some pseudocode in your own language, in your own native language, right? If you cannot define some solution in your own native language, then obviously you cannot write that code in programming language as well. So this is very important. So programming is a tool you use to execute your solution. Okay, so it is a tool. We use programming in this course as a way of teaching computational thinking. So we are using programming, more specifically Java, but the main purpose is that so that you can uh, think computationally and write your solutions in computer programming. Okay, so programming can be learned just like any other skill. So don't worry if yeah, it's not like something that it should be in your genes or inheritance or something. No, you can learn. It's a skill. It's not a black magic. Okay, so there's no such thing as a coding gene. Yes, at first it may be challenging, nightmare, or something mind bending thing, but just like learning your first non-native language, right? So my hope is that you will think differently after this course. So these are the tools carpenter use to make different things, right? He or she can make furniture, different types of furnitures. So what are the main skills behind any successful carpenter? Not these tools, but he knows how to use these tools, right? With the help of these tools, like uh, carpenter can make a table or a bench, a chair, a cabinet, a bookshelf, a door, a bunk bed or simple bed, right? So similarly, programmer has some tools. So if you want to become a good carpenter, then obviously you would need skills to use that tools. I will focus on this thing again. You have to learn these tools, how to use it, where to use it, when to use it, right? So when you have good commands on these tools, you can make any application. You can make any type of furniture. If I'm talking about that carpenter thing, right? Then this is not a problem that that furniture would be a chair or it would be door or what would be the shape of the door, it would be big or small. So then these details are not important for a carpenter if he has a skills, if he has skills of using these tools, right? So similarly for programmers, we have tools. So in this course we would be focusing on these tools. We would be focusing on computational thinking and how to use these tools to make computer programs. Okay, so these tools are statements, variables, loops, functions, conditions. So if you know these tools, then you can make any computer program, any computer application. Okay, just like a carpenter, then you can make any application. All the applications that you are seeing nowadays are just consist of these tools or their advanced form of tools. Okay, so you have to learn these tools, when to use these tools, how to use these tools. This is very important for this course. So what are statements? Like they are instructions. X is equals to 20. This is one instruction. Okay, so one step is one statement. Then we have variables, loops, functions, and conditions, right? So in this whole course we would be using these tools, why and where we would be using loop, and why functions are more good for robust programming, right? So in this course we would be using Java, because Java is object oriented programming. They are widely accepted, easy to learn, market acceptance is there. At the end of the day, the language you use does not matter, right? As long as you develop computational thinking skills. So if you can solve problems, if you can think about how to solve a problem, then you can write in any programming language. In terms of software, you need JDK, you can download from the internet. For IDE thing, I'm using NetBeans, but you can use any other IDE, Eclipse or IntelliJ. Yeah. So you can use any IDE, and most of the time these IDE come with JDK as well. So yeah, do install some good IDE. So this is the end of the first lecture. So what to do next? You have to install JDK, you have to install IDE. If you have any question, comments, feedback, you can comment on YouTube video, and please share with your friends and keep learning. Bye.